So as I said, we can use each of these method to each of if we have the AC system, we can convert everything to impedance and phasor, and then use the same method we used before. Now I'm going to show how we can use the node voltage analysis if we are um, if we have the AC circuit. So again, assume that we have the source with the uh, no, so it's the current source. So we have a current source that's going to be 2 sine 100t, and it's connected to uh, the resistance 10 ohm, and then there is a capacitance with C is 2000 microfarad, and then there is a uh, inductance with L is 0.1 henries, and then there is another source which is going to be 1.5 cosine 100t. So assume this is what we have, and this is the R, and we want to analyze this circuit um, and find the voltage at this um, V1 at this node here. So this time I'm going to use the node voltage method to actually analyze the circuit. So again, we have the AC. So what we do is that first we are going to rewrite all the um, what we have sources as a phasor, and then all these as a impedance. So the first one I have here is the 2 sine 100t, and then I go ahead and convert it because it's a sine. I have to convert it to cosine, so I have go ahead and say it's a cosine 100t minus 90, and then I can write it as a phasor. So I can go ahead and say if I write it as a phasor, this one is going to be 2 with angle of negative 90. The second source that I have here is 1.5 cosine 100t, and then I can direct, because it's a cosine, I can write it as a 1.5 with angle of 0, because the theta is 0 here. Remember that I can use this calculation in a phasor because both of them, they have the omega, the same omega t. So it's 1100 t and the 100. If they have the different um, uh, omega, then we cannot do this calculation. Same here. So this is the, if I come here, uh, this is the omega. So I know this is the omega t. So therefore the omega is 100. But this is omega t. So I can find the omega is 100. So now I can come here and start to find the impedance for each of these three as well. So I will go ahead and say this is for the R, the ZR is simply just the R. So it's going to be um, um, 10. For the this the C, the ZC is negative J over omega C, which is going to be negative J over the omega is 100, and the C is 2000 times 10 to the negative 6. So it's going to be, if you do the calculation, so it's going to come out at negative J 5. The same for the ZL. It's going to be J omega L. So it's going to be J times 100. The omega is 100 and the L is 0.1. So it's going to come out as J10 that we wanted. So these are gonna be our sources and then the impedances. So now I'm gonna rewrite this again, redraw this circuit again. So I have the sources here with angle of negative 90. So this is the first source. Then I have this resistance with ZR R of 10. Then I have this capacitance with ZC of negative J5. Then I have this inductance with the ZL of J10. And then I have this source with, so this is the 2, and there is 1.5 with the angle of 0. So this is the, now after I redraw that, this is what I'm gonna have. Now I'm gonna just use the node voltage method. So first find the reference point. So I'm going to go ahead and say this is gonna be my reference node here. So basically these two are connected to my reference and assume the voltage is 0 here. And then I can go ahead and say this one is the V1. This one is the node 2, V2, and assume this one is the V3 that I have. So I know that in the node voltage method, we assume the current leaving each node. So we know that here we have the current leaves this node. So I would call it the I1. I will call it I2, and I will call this I3. The same here, we have the current leave, assume the current leaving there. So I'm gonna yeah, 1, 2, 3, so I4. Assume this is the I5, and this one leaving also is gonna be I6. So now I come here. Let me draw a line. So write the next here. So I can write the KCL at 1. Again, assume this is the node 1, this is the node 2, and this is the node 3, and I know the KCL node 1 tell me the sigma I should be 0, and therefore the I1 plus I2 plus I3 should become 0 at that node 1. And so the I1 is, I know is in the opposite direction of this coming, and I know the magnitude of, so the I1 is the negative, because it's the negative of that. So it's going to be -2 with angle of -90. In other words, it's going to be something like that. So it's going to be negative of 2 with angle of -90. So this is the one here, because the I1 is the opposite direction of that. So I put the negative sign here. The I2 is the voltage at the beginning minus the voltage at the end divided by the impedance or the resistance. So it's going to be the voltage at the beginning, which is going to be the V1 minus V3, which is going to be the 0 divided by ZR. And then for the I3, again, is going to be beginning, the voltage at the beginning minus V2 minus voltage at the end divided by the resistance in between, which is going to be the ZC. So as I said, we consider the Z as the way we work with the resistance. So if I go ahead and substitute that, so I know the V3 is 0. So this is 0. So I'll go ahead and substitute them. So I can go ahead and move this to the other side. So I'm going to have the V1 divided by 10 plus V1 minus V2 divided by ZC, which is going to be negative J5, and is equal to 2 negative 90. So it's, this is going to be this equation, and if I go ahead and do the calculation, eventually, if I simplify this equation and do all the calculation, I'm going to get 0.1 plus J.2 V1 minus J.2 V2 is equal to negative J2. And remember that this one is negative J is because the angle is negative 90 degrees. This one is just a negative J2. If you convert it to from the polar, if you convert it to rectangular, because it doesn't have any real part, and negative 90, so it's negative J2. So this is the first equation I'm gonna get. Now I can go ahead and write the KCL at point 2. So if I go ahead and write the KCL at point 2, again, the sigma I at point 2 should be 0. Therefore, the I3 plus I4, I4 plus I5 plus I6 should be 0. So if I go back and show, so I4 is the voltage at the start minus voltage at the end divided by resistance between them. So V2 minus V1 divided by ZC. That's going to be V2 minus V1 divided by ZC. Then plus I5, so I go 5. So I5 is this one, V2 minus V3 divided by the resistance between, which is going to be the ZL. So V2 minus V3 divided by ZL, and then this one, the I6, we know the magnitude is 1.5 with angle of 0, and we know what the direction we chose is opposite of that, so it's going to be negative of that. So it's going to be negative of 1.5 with angle of 0. So it's going to be negative of 1.5 with angle of 0, and it's going to be 0. And now I'm going to replace these. So V2 minus V1 with the ZC, which the ZC is negative J5, plus V2 divided, because this V3 is 0, we know that, so this is 0, divided by the ZL, which is the J10, and I take to the other side, so it's going to be 1.5 with angle of 0. So if I go ahead and do the calculation and simplify that, what I'm going to get is 0.2J plus, sorry, what we get here is a negative J.2 V1 plus J.1 V2, and it's going to be 1.5, because this one again, it has the angle is 0, means that it is on the real it's on the real axis, so it's just 1.5. So this is the second equation. So I have the first equation here, and then the second equation here. So if I put both of them in the so 0.1 plus J.2 V1 minus J.2 V2 is equal to negative J2, and then we have negative J.2 V1 plus J.1 V2 is 1.5. So I have this equation. So it's a system of equation. If I solve them as the system of equation we had before, so can write it the same as 0.1 plus J.2, and then here we have the second one is the negative J.2, and then we have the negative J.2, and then we have J.1, and then we have V1, V2, and then we have negative J2, and we have 1.5. And if we solve the system of equation, we get V1 is going to be 14 plus 8J, and V2, so J8, so, and V2 is become 28 plus J1. So, and then you can go ahead, for example, for the V1, I'm going to say, so the V1 is 14 plus J8, and you can write it in the polar format. It's going to be 16.1 with angle of 29.7, and then you can go ahead and convert it to time domain as V1t is going to be this magnitude, 16.1 cosine the omega t, the omega that we have here, omega t is 100t, 100t plus the angle, which is going to be 29.7. So it's going to be the V1. The same as this, we can write the V2 as well. And then this is how we actually solve the circuit in the node voltage method.